This is A2Further Maths, and we're on Unit 8, Hyperbolic Functions, and we've come to the end here. So we are dealing with some hyperbolic functions and some just kind of trig functions, inverse trig functions and all that, and bringing together then just some other methods of integration at the end. So not necessarily hyperbolic functions here, but a combination of the two between that and trig. So a couple of new integrals then that we need to be able to do is 1 over px squared plus qx plus r, and 1 over the square root of that. Where p, q and r are constants, can be integrated using one of the following standard forms. If we can rewrite this, and effectively we're going to complete the square to get it into a different format, and then we can kind of do it then from there. So it's a good wee technique if we can get our head around it. So the following examples illustrate the method required. So we'll go for part A first of all here. So we're asked then to integrate 1 over x squared minus 2x minus 3. So first thing I've written is notice that x squared minus 2x minus 3, if we complete the square, I'm not going to go through it really, but we can write then x minus 1 all squared. That gives us, obviously that's going to give us our minus 2x. What I've done, I've halved the minus 2 to get the 1. That creates a 1 that we don't want, and so then it's going to be a minus 4. So how does that help us? That means we can rewrite our original question. Make sure you can see this okay. Therefore, the integral of 1 over x squared minus 2x minus 3 dx can be written as the integral of 1 over x minus 1 all squared minus 4 dx. And if I let u equal x minus 1 and start to set this up, then it's going to be the integral of 1 over u squared minus 4 du by dx. Then it's just going to give me a 1, and that means dx by du then is obviously going to be a 1 as well. So a dx by du then is just going to be a 1. So it's just going to be u squared minus 4 du. I hope you're okay with a couple of different moves there, because that effectively goes to 1 over u squared minus 4 dx by du, but because the dx by du is just 1, then it just disappears from there. This is one of our standard ones. Let's see which one it is. So it's something x squared minus 4 effectively. So what do I have? So it's a bit like this one, x squared minus that, so it's going to be then 1 over that. So that goes to a quarter ln u minus 2 u plus 2 plus c, and then my final line obviously changes back to an x. That's what I started with. Of course u is x minus 1, so that's going to be x minus 1 minus 2, so that's x minus 3 all over x plus 1, and then we have then plus c. Part B then is reasonably similar, so it's the integral of x squared minus 2x plus 5. So again, we're going to complete the square there. I'm going to do it just over the page there with plenty of space in here. So x squared minus 2x plus 5 we can write as x, so I half the minus 2, as you remember, so it's x minus 1 all squared. That gives me a 1 that I don't want, so I subtract 1 and I add 5 then, so it's going to be plus 4. So how does that work out? The integral, which is my original question, 1 over x squared minus 2x plus 5 dx becomes the integral of 1 over x minus 1 all squared plus 4 dx. I'm going to let my u equal x minus 1 again, obviously dx by du, you can see this okay as 1 du by dx, so that should be du by dx if I've left the line there, hopefully you forgive me, is 1 as well, and so I get the integral of 1 over u squared plus 4 du. That then again, if we look back, so we're looking for an x squared plus something else squared. So what do we have here? X squared plus something else squared, so that's going to be then an arctan then of my x over a. So let's take a look then at this. So that would give us a half arctan u over 2 plus c, and we're a line away then, so that would be a half arctan x minus 1 over 2 plus c. Okay, on to example 2 then, and I'm sure you can see where we're going to go. We're going to take this and going to complete the square again, so we're going to consider x squared minus x plus 1, and that's going to be x minus a half all squared, so I have half the 1 there. What is that? That gives me a quarter that I don't want, so I take away a quarter and I add 1, so that's going to be then plus 3/4. Now we need to rewrite this because this kind of needs to be a square number here, so it's going to be x minus a half all squared plus root 3 over 2 all squared. Obviously to square that you just get your 3/4, so we can see where that puts it in a nice format for us, which is the way then we're going to need it. Therefore my original question, which is the integral of 1 over the square root of x squared minus x plus 1 dx equals the integral 1 over the square root of x minus a half all squared plus root 3 over 2 all squared dx. Same as the last couple, I'm going to let u equals x minus a half, then du by dx equals 1. That means dx by du equals 1 as well. So I can rewrite this then as the integral of 1 over the square root of u squared plus root 3 over 2 all squared du. Hope we're okay with that move. Now what one does that look like? That's going to be an x squared plus something else squared. Where are we? X squared plus an a squared, so I think that's where we're going to go with that. So it's going to be our shine. So using that formula then, we're going to have our shine u over root 3 over 2 plus c. So that's then going to be r shine. So what am I going to do here? Right, I'm going to times top and bottom by 2 to get rid of the fraction within the fraction, and change my u then to an x minus a half. So it's x minus a half times 2, so that's just 2x minus 1 all over root 3 plus c.